All right, let's talk about section 9.3, trigonometric functions of general angles. General angles just refers to angles in the xy plane as we introduced in the last section, so x and y axes here. All right, so if we draw some arbitrary angle in the xy plane, so it can go really anywhere, we'll take it to the third quadrant, I guess. If we draw in that angle, we call it theta. And if we sketch in a right triangle here, so we drop a line straight to the x-axis, no matter where we draw the angle, we can always draw a straight line to the x-axis, and we make a triangle here. Then this point right here, again, we're on the xy axis, will be x comma y. And because this distance here is x and this distance here is y, right? And then this distance here is going to be called r. And that r comes from, if you were to draw in a circle, that would be the radius. If you drew a circle with a center at 0, 0 that went through this point, then that would be the radius. But you just need to know that r is the distance from the center of that point. Now, since we have a right triangle here, we can write a relationship between x, r, and y. We can write this: x squared plus y squared is equal to r squared. All right, so that will be important information in a minute. And then of this angle, it turns out there's some interesting properties of sine, cosine, and tangent. Sine of the angle, so sine of theta, is going to be equal to the opposite side here, which is y, over the hypotenuse, which is r, so y over r. Cosine of theta is going to be equal to the adjacent side here over the hypotenuse, which is x over r. And tangent of theta is going to be equal to the opposite over adjacent, which is y over x. And then the reciprocal functions we can get just by flipping all of those fractions. So cosecant of theta is equal to r over y. Secant of theta is equal to x, r over x. Cotangent of theta is equal to x over y. All right, so let's do an example where this applies. So again, we're not solving for anything here, we're just finding the ratios, okay? So over here, let's find all 6 of them for theta whose terminal side contains the point -5, 3. So you think, okay, well, I'm going to go over -1, 2, 3, 4, 5, and then positive 3, 1, 2, 3. So something like this. You don't need to sketch these out every time unless it asks you to do it. But now I want to figure out what the sine, cosine, and tangent, and well, all 6 of them are for this point here. And I've got x. X is given as -5. Y is given as 3. And this distance here, r, right? I can figure out what that is by using this formula here, which is the Pythagorean theorem. In fact, let's even simplify this. R is going to be always equal to the square root, positive square root of x squared plus y squared. Okay, so what I'm going to do now is take and figure out r, and once I have r, I can go find the rest of the trig ratios. So r is equal to the square root of -5 squared plus 3 squared. All right, so that's going to be the square root of 25 plus 9, and so you get 5.8. So r is equal to 5.8. And then I can go figure out the rest of my the trig ratios. So sine of theta is equal to y over r, so that's just 3 over 5.8. Cosine of theta is equal to x over r, so that is just -5 over 5.8. Tangent of theta is equal to opposite over adjacent, in other words, y over x, so that is going to be 3 over -5. And then the reciprocal functions just flip. So cosecant of theta is going to be equal to 5.8 over 3. Secant of theta is going to be equal to 5.8 over -5. And cotangent of theta is going to be equal to -5 over 3. Let's go on to another one. So in this one we got the same question, except we've got the point 0, 6. So 0, 1, 2, 3, 4, 5, 6. So for this point, you'll notice that I can't make a triangle like I could in the previous examples. So your radius is just going to be whatever this distance is here. Okay, so r is going to be 6, x is 0, and then y is 6. Okay, so that when it happens to land on an axis, the r is whatever that distance is. So if it lands out here, it's whatever the distance is from the center, and so on. Okay, think r means radius of the circle, right? So if it doesn't make the triangle, then it's just the radius of that circle that would be created by going through that point. So we can then figure out the trig functions or trig ratios based on that. So sine of theta is equal to y over r, which is 6 over 6, which is 1. Cosine of theta is equal to x over r, so that'd be 0 over 6, which is just 0. Tangent of theta is going to be equal to 6 over, so y over x, which is 6 over 0, which is undefined. Okay, so with the other ones now, cosecant of theta is going to be equal to, well, 1 over 1 is just 1. Secant of theta is going to be undefined because we're going to flip 0 over 6. And so it's going to be 6 over 0, which is undefined. Sorry, I didn't give you enough space there, undefined. And then cotangent of theta is going to be flipping 6 over 0 to 0 over 6, and that's fine, it's just 0. Okay? And then so that's how you do those types of problems. All right, let's jump to reference angles here. All right, reference angle is the angle closest to the x-axis. So let's find the reference angle for each one of these. So for 710 degrees, I'm just going to sketch this out real quick. 710, so that's going to go around 360 plus another 90 would take you to 450 plus another 90 would be 540. And in fact, it's almost all the way around. 720 is all the way around, so it's just going to come up about 10 degrees short. Okay. So the reference angle is the angle closest to the x-axis. So you draw on your angle, and then you figure out, okay, what's the shortest distance to the x-axis? So it's that piece right there. So if it's 710 all the way around to this line, to the terminal side, and it's 720 to get to here, then that angle has to be 10 degrees. So the reference angle is 10 degrees. Okay, so for number 4, this angle is given in radians. So the first thing we're going to do is convert this to degrees. So I'm going to multiply by 180 over pi. The pi's cancel out. I got 5 times 180 divided by 6. So it's 150. So this is 150 degrees. It's easier for most students to think in terms of degrees. So I'm just going to sketch this out real quick. 150 is going to be, so here's 90 plus another 60 degrees. Because remember, 180 is the rest, 180 takes you to here. And so this angle here is going to be 30 degrees. So the reference angle would be 30 degrees. Okay, those are going to be important in a second. Okay, but reference angle, whenever you hear that word, you're thinking the angle closest to the x-axis. That's really important. So remember that. All right, let's do some of these problems here down at the bottom. So the kind of meat and potatoes of the lesson here is finding exact value of trig functions. And this table is going to come back and be useful. And so I put it back on here because it's going to be useful in this section. Okay, so to find the exact value of a trig function, you do 3 steps, and you should do these 3 steps until you're confident enough in them that you don't need to follow the steps. You can just kind of do it without following my guidelines. Okay, you're going to first find the reference angle given the question. You're going to figure out the trig function for the reference angle based on the table, and then you're going to check the sign, whether it's positive or negative. Okay. I gave you these special right triangles here again, just for reference, okay, but the table is really what you are going to want to be using. So let's go to the back and do a couple examples here. So for sine of negative 210, sine of negative 210, I want to figure out what the exact value is. Now, if you look at your chart, sometimes the exact value will come out to be a nice number, like a half or 0 or 1 or something like that. And then that's fine, like you can just write those down. Okay, but sometimes it will come out to be square root of 3, for example, or square root of 3 over 2. Those are not nice numbers, right? Those are numbers that are going to have to be rounded. And so we want the exact value for those. In other words, we want the root in the value. Okay, so let's go through this. I want to find the exact value without using a calculator. So I'm going to sketch out negative 210 so I have a visual in my mind of where 210 is. So negative 210 would go this way, it'd be negative 90, negative 180, then plus a little bit more to get to negative 210. The reference angle here then, that's step one, right? Step one is find the reference angle. So the reference angle is going to be 30 degrees because it's 180 to here plus another 30 to get to 210. Okay? And so reference angle is 30 degrees. Okay, so I'll write that down. Step two, following the steps from the other side of the notes, is figure out what is the sine, well, hold on, I'm doing sine, right? So I'm going to find the sine of the reference angle. In other words, I want to know what is the sine of 30. Okay, so I go back and check. This one's going to happen to come out nice. Sine of 30 is 1/2. Okay. So for step three, then I check the sine of the trig function, okay? And I should have mentioned this before. So in other words, step three is check to see whether it's positive or negative, okay? And I should have mentioned this before, but you know what? I'm going to put it right on the back of the notes in this big area here, okay? We're going to prove this in a later section, but for right now you need to know that all trig functions are positive in quadrant 1. Okay? Cosine, sine, and tangent are all positive here. In this quadrant, only sine and cosecant are positive. Only sine and cosecant. In this quadrant, only tangent and cotangent are positive. And then in this quadrant, only cosine and secant are positive. All right? Everything else is negative. So like in this quadrant right here, since that's where the angle lands, the angle lands in quadrant 2, then this must be a positive value. So sine of negative 210 is going to be positive 1/2. Another way to say this is that these two, the sine of the reference angle and the sine of the angle that we're given, will be the same except for possibly a negative sign. In this case, it wasn't an issue because the sine quadrant is here in 2. That's where the angle landed. So it's going to be positive. Let's do a couple more of these. Tangent of 5 pi over 3. Most students think better in degrees, so we'll convert this real quick to degrees. And times this by 180 over pi. 5 times 180 divided by 3. 300. This is 300 degrees. Okay, so I'm going to sketch that out so I can find the reference angle. So 90, 180, 270, 300 is an extra 30 degrees there. Okay, so that's what 300 looks like. And then I'm going to figure out the reference angle. Well, that's the distance to the x-axis. The shortest distance to the x-axis is here. That's going to be 30 degrees. 60 degrees. Sorry about that. Okay, so that's step one, is find the reference angle. Step two, find the trig function of the reference angle, tangent of 60. So I go check my chart. Tangent of 60 is the square root of 3. Then I check which quadrant is it in. It's in quadrant 4. Quadrant 4, everything is negative except cosine and secant. That means that tangent is negative. So the actual answer then, the final answer for tangent of 5 pi over 3, or 300, however you want to write it, is equal to negative square root of 3. Again, negative because it's in the quadrant where only cosine is positive. All right, last one. Secant of negative 3 pi over 4. Again, start off by converting negative 3 pi over 4, and then convert it to degrees, and okay, so I'm going to convert this to degrees first, so times it by 180 over pi. 3 times 180 divided by 4 is equal to 135. All right, so 135 I'll sketch real quick. Here's 90 plus another 45 gives me 135. Reference angle is 45 degrees. So that's step one, is figure out your reference angle. Step two, figure out what secant of 45 is. So you check the chart. Secant of 45 is square root of 2. And then step 3 is to figure out whether it's positive or negative there. So secant of negative 3 pi over 4. So our final answer is going to be, so we check the quadrant. It's in this quadrant where only sine and cosecant are positive. Secant, so secant will be negative here. Okay, so my final answer will be negative square root of 2. Again, these things will be the same except for possibly a negative sign. And that wraps up finally section 3.